In this video, we introduce StereoTac, a new vision-based sensor that combines 3D vision with tactile sensing. The sensor is made from several components, including two cameras separated from a small distance, that are used to acquire 3D close-up images through stereoscopy. For tactile sensing, the sensor relies on a semi-transparent membrane as well as red and blue LEDs that are spread on the entire perimeter of the sensing area, to provide a depth image of the tactile imprint through photometric stereo. In vision mode, the sensor turns off its internal LEDs and increases the camera exposure to allow more light in. For example, here is a scene first photographed by a standard, off-the-shelf camera. The image shown here is a 2D image of the same scene from a different perspective, acquired with one of StereoTac's camera through a semi-transparent reflective membrane. Using pictures obtained through a membrane in both cameras, StereoTac can acquire a 3D representation of the nearby environment, as shown in this video. In tactile mode, the sensor turns on its internal LEDs and decreases the camera exposure to allow a minimal amount of light in. Since the LEDs provide a high level of illumination, the cameras are minimally affected by external lighting which is nevertheless filtered. This allows the camera to capture the deformation of the membrane through photometric stereo. StereoTac could be used for different manipulation tasks. Here we show a simple application where the sensor was mounted on a robot to first reconstruct the representation of an object. Using the known end effector pose at each location where 3D images were acquired, the raw, unfiltered data related to the segmented object can be stitched together to provide a more complete representation. With the object's geometry and location known from StereoTac's perception, the robot can now make contact with one of the object's corner. Finally, using the gradient images, the tactile imprint of the object can be inferred.